Alright guys, this is lab 3.5 for biology, which is our ocean acidification lab. Basically what we are trying to show is how CO2 emissions from burning fossil fuels goes into the atmosphere, but also goes into oceans to be dissolved. And what this kind of does is, as the CO2 is in the ocean, it kind of reacts to the water and forms a, carbonic acid, which basically just allows, or which releases hydrogen ions. So I'm just looking at notes. What we've seen is the more hydrogen ions in the water, the more, or the higher the acidity levels are. And the higher the acidity levels means that the pH levels will drop. And this can ultimately just create an uninhabitable ocean. Which affects mostly shelled creatures. It'll actually start deteriorating their shells instead of kind of helping create them. If that makes sense. I will first go over the some of the questions. Like I said, basically what it is just the reaction of CO2 and the ocean waters and everything like that. But number two, are you concerned about ocean acidification? Explain why or why not. I say yes. I'd be concerned about this problem because our oceans are a pretty big part of everything that we do in reality. It houses a lot of our food and a lot of the base food for our food webs and just nature in general. If we start seeing a decrease in shelled creatures and just fish in general and everything like that, then we're going to be seeing a lot of nature that's not going to be fed, which means that it's going to affect the entire food pyramid, or not food pyramid, food webs. And everything like that. It looks like our cabbage is almost done, so I will see you then. Alright guys, as I stated in the last clip, we are here to do lab 3.5, the ocean acidity lab. I think that's what it's called. Here today we have baking soda, two different types of pop. I just wanted to see how they would both react. So that's Pepsi and Sprite. We have the ammonia all-purpose cleaner. We have white vinegar, and then we have lemon juice. Okay. In front of it, we just have the teaspoon already measured out, so that'll just be a quick, easy add-in instead of sitting here waiting on measuring. So right now, currently, none of this has been messed with. They're all a really dark purple, so we're going to see how that changes. The first is the baking soda. Alright, so with the baking soda, we noticed that instead of it being a dark purple like usual, it actually turns to more of a blue. So that the baking soda is actually the base level for the pH. So that's going to be right in the middle. Anything above is going to be more of a pinkish. Anything below is going to be more like a yellow to brownish. Okay. Next is the Pepsi. Alright, so we can see with the Pepsi it didn't change too much. Instead of being a like super dark purple, it kind of turned into, I don't know how to describe that. I mean, it's still kind of purple, but it's like turning pink. So it's just a little higher than this. Next is the Sprite. Alright, the Sprite is actually a little more pinker than the Pepsi, so that's kind of good to know that your different sodas are going to have different effects. Next is the Ammonia, which smells awful. Alright, that one's really close to the baking soda, but that is more of a like a green instead of the blue that one is. So I would say that that's less acidic than the baking soda, if I have that right. And next is the white vinegar. Alright, that one is super pink, so that's very acidic. And the last thing is the lemon juice. Well, actually, no, second to last. And that's, instead of being the real clear pink like the vinegar is, the lemon juice is actually more of a solid pink or a murky pink. Or, yeah, like murky pink. So, what we're kind of seeing is lemon juice and vinegar are your most acidic things that you can, or that changes the pH really, like, a lot. The next is going to be the Sprite and the Pepsi. Sprite is a little more than Pepsi, as you can see within those colors. I'll move that actually. Then I would say it's the Ammonia all-purpose cleaner. It's just a little greener and brighter than the base baking soda. Next, we have this last cup that we have to blow air into for an entire minute. That's gonna suck. Alright. So someone's gonna set the stove real quick for a minute, and we'll begin. So what this showed was me blowing CO2 into the pH indicator that we created with the red cabbage, and it almost would fit right in between the Pepsi and the Sprite with how much I was able to put in within that minute. So that was kind of interesting watching it. Like as I was blowing into it, like you would see like a burst, and all of a sudden you'd see like a little bit of like purple come in. It was just really cool watching it mix. So, I think that's all. I think it would be really cool if I had different or more tests to kind of go through and check out. But I thought that was really cool, just having the different colors and how it reacts. That's all. Thanks.